Hey MIS, this is Ashton from the ISP Lab. Today we're working on this receiver from a Symphony, and so I've got this test jig set up to try and fix it. I've confirmed it has a bad brightness on channel 1. So here's the test setup. I'm going to go through and explain it to you. I've got the network analyzer putting out a 63.6 megahertz signal, just like the coil would, and that's going into the MR signal input. I've got the test jig set up to select that MR signal input here, and the path, here's the switching circuitry, switches from either a test or the coil signal or the reflected power from the RFPA. That goes into the first stage mixer. Goes through some filters to get rid of the harmonics from that mixer and the various frequencies you don't want. The LO is also coming from the transmitter module that I have here. And after that goes through there, it goes into the second stage mixer, which brings it down to 1.4 megahertz for the ADCs that are over here. So I'm actually looking at the input to one of the two ADCs, and we can see here that it's got 1.4 megs at 3 dB and not a lot of other frequency content, which is what we want to see. But moving this test point to the second ADC, which goes through these two op amps, you can see all of this frequency content that's there, and the ADC is actually going to see all of that. So we're kind of, we've been led to this bit of the circuitry here, and we pull out our handy dandy thermal camera, because most bad components will tend to have some extra heat on them. And we can see, just with the circuit overview, those two op amps are here on the screen. You can see they are pretty bright, especially that one on the bottom. So this is where we're going to look. We're going to replace those and see if that fixes the issue. This instrument is a great instrument right here. As you can see, I can actually see the data coming out of the back of the board too. I'm checking that out just to make sure the ADCs are functioning.
Okay. Good job, Ashton.
Thank you.